the screen. Okay, test is over. Hi. Okay, we're going to review transition metals. You have this in your notes, or you can use your handy dandy periodic table that I gave you and just do the math. What you have over here is the group 1 elements usually form a positive 1, the group 2, 2 plus. This gives you the transition metals. They do some weird things, so you might want to confer with this chart before you do anything. Group 3, group 4, group 5 elements tend to not form ionic bonds. They tend to form covalent bonds, which we will talk about in the next chapter. So these guys, they have a little too much to give things away. They have not enough to just need 1 or 2. So they tend to form covalent bonds, which we will talk about in chapter 4. And then your group 6 and group 7, which are going to form -2 and -1. So this is just a review of this because we will use it later. Okay. Metal atoms generally form positive ions. You remember this. This again is review. They form positive ions by what? Losing an electron. So if you remember correctly, we said when you give something up, it gives you a positive feeling. Remember we said that? That's what we're talking about here. So metals form positive ions by losing an electron. You form a negative feeling by taking things from people. So gaining an electron. The number of electrons lost or gained can be predicted by knowing the number of, come on, remember, super fun, valence electrons, or looking at your periodic table, or doing it. You don't have to count them and draw out the big giant circles like this. You can look at a periodic table. The number of valence electrons are basically written in your chart as, let's put it in red so you know what it is the family or group number for main group elements. You can go back and refer to this chart up here if I give you some of these super fun transition metals. But transition metals do some different things because I have a d orbital and we're not talking about orbitals, so just trust me. Transition metals also form ions by losing electrons, but they are not as predictable. Transition metals can lose 1 or more d electron in addition to some s electrons. It's crazy. So basically, transition metals are kind of doing their own thing. But you can look at this handy chart here if I give you one of these transition metals, and that will be helpful. Okay, moving on to naming ions. It's just like naming babies, only babies are cute and it's fun, and this is not fun. It is fun. It's chemistry fun. Perhaps not the kind of fun you were hoping for today. Okay, naming ions. Metallic ions, we like to call them cations, are usually given the name of the metal followed by the word ion. So things like, let's have an example, which I'll put in red. So let's say potassium, and then we're going to put the word ion. Sodium, ion. These are important. What's interesting here is you will all the time hear these being used just as potassium and sulfur in biology. I will use them mistakenly in physiology, but you know from our experiment in class. So if I were to actually take pure potassium and put it in your body, good things or bad things? Bad things would happen to you. So basically, people take out the ion, but it's super important because if I put pure potassium in your body, no good would come from that. Death, very swiftly, death would happen because potassium reacts with water. So it's a potassium ion, which does not react with water, which is what is in your body. You have a sodium-potassium pump, which is super important. It's basically all the physiology we talk about. I'll say the word sodium-potassium pump potentially 1,000 times. And so either one of those things, if I put them in your body as pure potassium or sodium, you would explode. So very often we take the ion off, but it actually is important, especially when we're talking about pure chemistry. Okay, so this is how you name ions. Potassium, you use the word ion. Ions of transition metals. Again, the transition metals, they're like the problem children. Ions of transition metals, which can form more than one cation, are named by 2 systems. An older system, which uses os at the end of the metal, or a newer system with a Latin name. Basically, sometimes these have, this is fairly important, sometimes they have these like iron, oh like iron 2. You've seen this maybe before. Iron 3. Sometimes that is the newer system, which makes more sense. And it's easy to know that these are cations. It's a -2 or -3 charge. Anions are named by dropping the ein or the ogen from the end of the name and adding "-ide", followed by the word ion, which people leave this out a lot. So things like chlorine is chloride ion. Very often we just call it chloride, but in reality the ion should be there, even though it gets left off of a lot of things. Chlorine, the ion of that is actually chloride ion. So you see how that works? You take off the "-ine" or the ogen and you put an "-ide" in there. This is super fun. Okay, polyatomic ions. Who's excited? I'm excited. I love polyatomic ions. Okay, some ions are composed of more than one atom. Yeah, it's true. Now we're like combining things like we did yesterday. Like the elements are dating, they're meeting up. They're like, hey, I need to fulfill my outer shell. So this is what happens. We form polyatomic ions. Some ions are, again, composed of more than one atom. These are called polyatomic ions. Atoms within a polyatomic ion are held together by covalent bonds. Remember, I mentioned this in class. Covalent bonds, they actually share. Nobody's taking anything from anyone else. They're sharing, equal sharing. And so there's not this like negative or positive charges because you don't feel that negative feeling when you don't take things from people. So atoms with polyatomic ions are typically held together covalently, which means they're sharing. Many polyatomic ions have important biological uses. So again, they are biologically important, and you'll hear me say them all the time. Potassium, calcium, magnesium. And again, these are an ion. I say potassium, but you saw what happened if I would put potassium in your body. Bad things would happen to you. Again, every aspect of human physiology. If you stay with me till next semester, the sodium-potassium gradient in your body is probably the most important thing that's happening to you right now. Like right now, your body is super busy making sure that you have potassium on one side of your cell and sodium on the other side, and that's moving, and that's causing your neurons to fire and do all kinds of things. So if that gradient is off, well, your whole body is off and be super tired because your body won't be able to move. So here's some biologically important ones. This is just for your edification. I'm not going to make you memorize them, but the sooner you sort of get in the habit of looking at them, the easier it'll be because it does not end now. We will continue to use them in physiology. Okay, let's take a break with this one, and I will come back and talk to you about formulas of ionic compounds.